The race to colonize Mars is intensifying, with Elon Musk's SpaceX and the People's Republic of China emerging as key contenders. Musk's ambitious vision, initially focused on a simple greenhouse, has evolved into a plan to establish a self-sustaining human city on Mars. This audacious plan, envisioning a multi-planetary human civilization, contrasts with China's more calculated, systematic approach to space exploration. Both nations demonstrate a commitment to pushing the boundaries of space travel. The immense resources and determination displayed by both entities indicate a growing global interest in expanding beyond Earth. This competition signifies a significant moment in the history of space exploration. The ambitious goals of both nations highlight the global drive to explore and potentially settle other planets. China's Mars colonization efforts are already underway, evidenced by the construction of simulated Mars bases in the country's remote desert regions. These sites, particularly Mars Base 1 and Mars Camp, serve as crucial tools for training and preparation. These simulated environments mimic Martian landscapes, providing a realistic training ground for future astronauts. The facilities showcase China's commitment to developing the necessary skills and technologies. The facilities are designed not only for training, but also for research and public outreach, inspiring the next generation to pursue careers in the space program. The public-facing aspects of these projects demonstrate China's strategic approach to building public support for space exploration. China's Mars exploration strategy involves a phased approach, starting with robotic missions to gather data and scout potential landing sites. The Tianwen rover and orbiter missions are key components of this initial phase. This phased approach prioritizes data collection and analysis before committing to human missions. The robotic missions will help identify suitable locations and resources for future human settlements on Mars. Robotic exploration aims to thoroughly analyze the Martian environment before sending humans. China's plan, with its emphasis on methodical data collection, indicates a pragmatic strategy focusing on preparation and risk mitigation for potential future human missions. This systematic approach to robotic exploration is crucial for informing subsequent human missions and ensuring the success of any eventual colonization effort. SpaceX's Mars colonization plan, led by Elon Musk, centers on the development of Starship, a powerful rocket capable of transporting vast quantities of cargo. This approach focuses on massive payload capacity, crucial for establishing a self-sustaining base on Mars. The plan envisions a large fleet of Starships transporting materials for a 1 million-person colony. Musk aims for rapid transport to reduce mission duration, crucial for minimizing radiation exposure and astronaut health risks. This section details the scale of Musk's vision, emphasizing the immense logistical challenge of moving large amounts of material to Mars to support a sizable colony. The core of this plan is the deployment of a massive fleet of Starship rockets. Comparing China's and Musk's strategies reveals distinct approaches. China's plan emphasizes a methodical, data-driven approach with a focus on robotic exploration and resource analysis. Musk's strategy is more visionary, focusing on rapid deployment and the establishment of a large-scale human presence. This difference highlights the varying perspectives on the best approach to colonization. The contrasting strategies underscore the multifaceted challenges and diverse viewpoints in tackling this ambitious goal. Both approaches, however, share the common thread of achieving a permanent human presence on another planet. The inherent differences in these strategies reflect diverse philosophies and approaches towards this ambitious endeavor. The economic and societal implications of Mars colonization are substantial, particularly with China's rapid development. China's vast manufacturing capacity and economic growth offer significant advantages in resource allocation and production. This economic strength translates into the potential for faster advancements in space technology. China's rapid progress in its space program underscores a national commitment to space exploration. However, the potential for exploitation and abuse of resources and labor, common in rapidly developing economies, should not be overlooked. The contrasting approaches to colonization, driven by different economic systems, highlight the need to balance technological progress with ethical considerations. These economic factors influence the development and implementation of space programs. Chinese rover finds that Mars almost certainly had sandy beaches and an ancient ocean. China's Zhurong rover, a little vehicle that trekked around Mars for a year starting in May 2021, revealed something pretty incredible, evidence of what sure seems to be sandy beaches that once edged a large ocean. It's a relatively sure thing that Mars did indeed once have water. The hypothesized ocean likely existed around 3.5 to 4 billion years ago, when Mars was a warmer and wetter place than it is today. We name the ancient ocean Deuteronoilus, which I assume is named after Deuteronomy, the fifth book in the Torah, in which Moses delivered rousing speeches to the Israelites on the plains of Moab. And if it did exist, it took up much of Mars' northern plains. The idea that Mars had lots of water once upon a time opens up a million possibilities. Life as we know it came from the Earth's primordial oceans, and scientists think that a Martian ocean could once have played host to alien life. The Chinese rover spent a year bumping around Mars, using ground-penetrating radar to figure out what's going on deep below the red planet's current day surface. According to a report in the Proceedings of the National Academy of Sciences, which uses the unfortunate acronym of PNAS, between 33 to 115 feet down, the rover found layers of a material very similar to sand. All of it sloped in the same direction, like our beaches slope down towards the sea. After inspecting the data, researchers were able to map out what looks to be an ancient Martian shoreline. The Martian surface has changed dramatically over 3.5 billion years, said Guangzhou University's planetary scientist Hai Lu. But by using ground-penetrating radar, we found direct evidence of coastal deposits that weren't visible from the surface. Here on our pale blue dot, beaches take millions of years to form. Waves need to crash endlessly on shores to form sand. And if Mars is anything like Earth, that's likely also the case. Wave action and rivers flowing from mountains and tides probably all existed there, and probably existed for millions of years. And with oceans come life. The beaches would have been formed by similar processes to those on Earth. Waves and tides, Liu explained. Such oceans would have profoundly influenced Mars' climate, shaped its landscape, and created environments potentially suitable for life to emerge and thrive. Shorelines, according to Michael Manga, a planetary scientist at the University of California, Berkeley, are fantastic places to find evidence of extinct life. It's thought that the earliest life on Earth began at locations like this, he said, near the interface of air and shallow water. Since Mars is, to put it mildly, very far away, it's tough to be 100% sure of any theories. The Deuteronoilus ocean theory, however, has passed quite a few tests that could be considered near proof of existence. A primary part of this work was testing these other hypotheses, Penn State geoscientist and study co-author Benjamin Cardenas told Reuters. Windblown dunes were considered, but there were a few issues. First, dunes tend to come in groups, and these groups produce characteristic patterns not present in these deposits. We also considered ancient rivers, which exist in some nearby locations on Mars, but we rejected that hypothesis for similar reasons based on the patterns we saw in the deposits. And you don't typically get structures like this in lava flows either. Beaches simply fit the observations the best. Chinese researchers find past evidence of sustained body of water on Mars. Chinese researchers say they have found evidence suggesting that a massive ocean might have once existed on Mars in ancient times after studying data obtained by China's first Mars rover Zhurong, which landed on the red planet back in May 2021. During its Mars mission, the groundbreaking rover carried out key geology detection work with a ground-penetrating radar to investigate the underground structure and possible subterranean ice deposit on Mars, with a research group saying the collected data reveals evidence of an ancient ocean on Mars. Research results have shown that the sedimentary structures of soil ranging from a depth of 10 to 35 meters at the northern hemisphere of Mars shares high similarity to coastal sediments on Earth, showing that oceans once existed in the middle and lower latitude areas of Mars. This discovery indicates that the region once had a stable and sustained large body of water rather than a temporary melting event. Liquid water is one of the essential conditions for life, and the findings suggest that Mars may once had an environment suitable for the origin and development of life. In particular, the coastal sediments we found provide strong evidence that the water body existed for an extended period. said Liu Hai, Deputy Dean of the School of Civil Engineering and Transportation, Guangzhou University, who is one of the leading scientists of the research project. Liu noted that various factors over a long passage of time have resulted in the vanishing of the ocean. Despite excitement around the findings, Liu stressed that proof of living organisms on the planet at any point in its history remains inconclusive. There are multiple possible reasons for Mars losing its oceans, including the weakening of its magnetic field, which led to solar winds stripping the Mars atmosphere, and reduced activity in its planetary core. These factors likely contributed together to Mars's transition from a warm, humid environment to a cold, arid planet. Based on current research findings, there is no definitive evidence proving that life once existed on Mars, he said. The new findings now offer a solid foundation for further geological investigations on Mars, according to Liu, who added that this can now play a big role in future manned missions. Given the existence of ancient Martian oceans, Liu said some of the water likely moved underground in the form of ice as the planet cooled, which he believes could serve as a key water resource supply for future Mars bases. Liu said research teams will continue analyzing data obtained by the Zhurong rover to further understand the planet's geological makeup. Our next step is to focus on analyzing ground-penetrating radar data of the Mars subsurface detected by the Zhurong rover. This will provide richer underground scattering information and allow for a more detailed understanding of the geological structure of Mars' subsurface, said Liu. The Zhurong rover successfully landed in Mars's southern Utopia Planitia May 2021 and had traveled 1,921 meters by May 2022 on the Red Planet, collecting abundant scientific data. China and SpaceX envision reaching Mars in different ways. While Chinese scientists vowed to bring back rock samples from Mars to Earth, with 2 unmanned vehicles in 2028 to 2031, their American counterparts said they will launch an uncrewed spaceship to the Red Planet in 2026 and a crewed one in 2028. The China National Space Administration, CNSA, plans to carry out its Tianwen-3 mission through 2 launches in 2028, aiming to bring back 500 grams of rock samples from Mars and searching for signs of life on the planet. In the Tianwen-3 plan, the lander or sample collector, landing ascending combination, and deliverer or return module, orbiter-returner combination, will be launched to Mars separately. Liu Jizhong, director of the Lunar Exploration and Space Program Center of CNSA, said at the 2nd International Deep Space Exploration Conference in Anhui on September 5th. Chinese space engineers will have to tackle key technologies such as collecting samples on the Martian surface, taking off from the Red Planet, rendezvous on the orbit around Mars, as well as planetary protection, he said. Some media, including the South China Morning Post, said the launch of the Tianwen-3 mission to Mars in 2028 is 2 years earlier than previously planned. But in fact, Sun Zezhu, chief designer of the Tianwen-1 mission, had already said in April last year that the earliest time for China to launch space rockets to Mars for a sampling mission would be 2028, while the mission probably would involve 2 rocket launches.